Hey guys, happy Monday. I hope you guys are ready to start your digital lessons for the week. Today we're going to go ahead and start our geometry unit. So our first introduction is going to be into angles and the relationships that angles can create. So the first thing I want to give you is some quick reminders from 6th grade, the different types of angles that we have. So an acute angle, if we're talking about an acute angle, an easy way to remember it is it's a cute little angle. So it's an angle that is less than 90 degrees. It's an angle that's going to be less than 90 degrees. So it might look something like this. That would be an acute angle. Okay, we also have a right angle. And for the definition of a right angle, it is exactly 90 degrees. And it looks like a little L shape. Okay, so it forms that little L. Sometimes we have a little box inside to indicate that it is a 90-degree angle, so that's something that you might want to look for. Then you've got an obtuse angle. So some people like to say it's the obese angle to help them remember. Obese and obtuse are similar. It's more than 90 but less than 180. So greater than 90 degrees but less than 180 degrees. So it opens up a little bit wider. And then the last angle that you guys learned about last year is the straight angle. So it kind of looks like a line. So it's exactly 180 degrees. Okay, so those are just the types of angles that we know that we have. I quickly want to also remind you of how to name an angle. So to name an angle, there are different ways that you can actually go about naming an angle. So for example, if I give you the following angle here, sometimes your angle might have 3 points on it. 2 of the points might be what we call endpoints, and 1 point is what we call is the vertex of the angle. So if this was maybe A, W, and R, then one way we can name it is starting at one endpoint. So maybe I might start here at A, travel to my vertex, and then end at the R, the other endpoint. So that's one name that we could provide for it. Angle A, W, R. And we give a little angle symbol to represent that it's an angle. Let me rewrite that so that you can see it better. So we have a little tiny angle symbol, and it's AWR. That's one way to name it. So if I say AWR, this is the angle that I'm referencing. You could also start it in the reverse. Instead of starting at A, maybe you might start at R. So start at R, travel to your vertex, W, and then travel to your last point, your end point. So I might also call it angle RWA. I could also name it based off of just the vertex itself. Not always as reliable, because if you've got multiple angles with the same vertex, that makes it a little bit more difficult. But that is one way that we can identify the angle, is angle W from the vertex. And then sometimes there might be just a number inside of it. Maybe I have multiple angles all connected together, and I just might put a little tiny number inside. So like, let's say that this had a number 1 inside of it, then that would be angle 1. So those are just different ways that we can go about naming our angles. Again, the most common way to name your angle is by the 3 points that create your angle. Starting at one endpoint, traveling to a vertex, and ending at the other endpoint. Those are the more common ones. So you want to focus mainly on 1 and 2. So angle AWR or angle RWA. Those are the better ways of naming your angle. All right. So those are just some quick reminders on how to name your angles. So now let's talk mainly about relationships of the angles. So our angle relationships. Well, actually, let's go ahead and do an example real quick, or a problem where you just name some angles, maybe identify the type of angle that it is. Let's just do 2 examples of that so that way you make sure you've got that under your belt. So I want you to name and type it. So name what kind of angle that would be called and what type of angle. Is it an acute, a right, an obtuse, a straight? So we'll do that for 2 examples. Make sure that you have that under your belt. So let's go with the following. So go ahead and pause the video so that way you can go ahead and practice naming the 4 different ways that we might name these angles. And then go ahead and check your answer after you unpause. Okay, so one way that you could actually name the angle is if I started at X, traveled to the F, and then ended at Q. So that's one way to name it, would be angle XFQ. Another way to name it is the reverse, starting at Q, traveling to F, and then up to the X. So it might be angle QFX. A third way to name it would just be to focus on the vertex itself. So that would be angle F. And then a fourth way to name it would be to focus on the number that might be inside if it has a number. So like angle 3. And then the type of angle, this is an angle that would be less than 90 degrees. So therefore, this is going to be an acute angle. Okay, if we're looking at problem number 2. Problem number 2, we'd start at L, go to S, and then end at A. So one way that we'd be able to name this angle would be angle LSA. We could also start at A, travel to S, and then go up to L. So that would be another way to be able to name it. So angle ASL. We then might also be able to focus on the middle point, the vertex point. So angle, another way of naming it would be angle F, or naming it based off of the number that might be inside of it. Again, that number is not always going to be inside. Sometimes it does, sometimes it doesn't. So angle 2 could be a possibility. And because we have that little box in the corner, that does make this a right angle. Okay, so now let's go ahead and we're going to turn to page 56. We're going to go on talking about angle relationships. So we've talked about the different types of angles. We've talked about naming your angles. Now let's focus on the angle relationships that can exist. So we're on page 56 now. So the different relationships. We have one relationship that we'll focus on is called complementary. And now with complementary angles, that means you've got more than one angle. You've got 2 or more angles that are going to form a relationship of exactly 90 degrees. So that means you cannot have a right angle in a complementary angle relationship. Because if you have a right angle, then you have no other angle that can be added with it to create 90 degrees, because a right angle is already 90 degrees. So again, these are relationships. Think about if you have a relationship, there has to be more than one person to have a relationship. It's the same thing with angles. You have to have more than one angle in order for there to be a relationship. So here, complementary, that means we have 2 or more angles with a sum. And remember the word sum means you're adding those angle measurements together. It has a sum of exactly 90 degrees. It has a sum that is exactly 90 degrees. So if I have an angle that is 30 degrees, or if I have an angle that might be 60 degrees, so I have a 30-degree angle and a 60-degree angle. If I add those two angles together, 30 plus 60, that's going to equal 90 degrees. So that makes a complementary angle relationship. Okay, then we've got a supplementary angle relationship. And with supplementary angles, it's the same concept as complementary, except instead of it having to equal exactly 90, supplementary has to equal 180. So again, you have to have more than one angle in order for there to be a relationship. So it's two or more angles with a sum. And remember again, sum means you have to add the angles together. You add them together, has a sum of exactly 180 degrees. Okay, so for here I might have an angle that is 140 degrees. And then I might have another angle that is 40 degrees. And if I take 140 and I add it with 40, that's going to equal 180 degrees. Okay, then we have one more relationship that we're going to focus on. So for these first two relationships, you had to add the angles together to see if they would equal something. With our, sorry, that was supposed to be a 3. With our third angle relationship, these are called vertical angles. That means that these angles are exactly the same measurement. These angles are congruent, which means they are equal to each other. So if one of them is 30, the other's 30. If one of them is 56, the other is 56. That means they are exactly the same angle, but they're also formatted in a manner that they're directly across from each other when we've got lines that intersect. So let me go ahead and write the definition down real quickly so that you can get that. They are angles that are directly across from each other, formed by intersecting lines. And the most important thing that you need to keep in mind is that they are congruent. That means that they are equal. They are congruent, equal, same size. Okay, so when I say that they are intersecting lines, that means I have two lines that are going to intersect, and it's going to form 4 angles. So I've got, maybe this is 133 degrees. That means directly across from it, right across from it, is also going to be 133 degrees because they are vertical angles to each other. And the same thing for here. This is 47 degrees. That means directly across from it should also be 47 degrees. So like maybe this is angle A and this is angle B. Well, angle A and angle B are vertical angles. Okay, so that means that angle A is equal to angle B. And then likewise, maybe this is what I'm going to call angle C, and this one I'll call angle D. It's the same exact idea. Angle C and angle D are vertical angles. So that means they are equal to each other. Angle C will equal angle D because they are equivalent. They're congruent to each other. Now to think they are directly across from each other, think about it like you've got neighbors. So if you live in a house, you have next door neighbors. Next door neighbors are neighbors that, you share maybe if you're in an apartment, you might share a wall with them. If you're at a home, there's one on your left side, one on your right side. Those would be adjacent. They're adjacent to you. They're next door to you. Vertical neighbors are the ones who are directly across the street from you. So if you open your front door, you can look out and you see their front door. So it's like this. Angle C is next door to angle A and angle B. It's adjacent to angle A and angle B, but it's a vertical angle to angle D. If it opens up its door and looks directly across the street without looking left or right, it looks straight across the street, it comes to angle D. And the same thing for angle A. If angle A opens the door and looks directly across the street without turning its head, it looks straight at B. Okay, so that's vertical angles. They're directly straight across from each other without curving left or curving right. They don't have to turn their head. They look straight ahead, and there's their angle partner. Okay, so those are the angle relationships. So what I want to do right now real quickly is give you guys a couple of examples to where you're going to identify whether it is a complementary, a supplementary, a vertical, or neither. So I'm going to go ahead and turn the page to page 57 so I have a little bit more room. So you're going to state if the angles that I'm showing you, if it's complementary, supplementary, vertical, or neither. Because it doesn't have to have a relationship, right? There's people around you that you come in contact with, you don't have a relationship with them. They're just there. Okay, it's the same thing here. There are such things as angles that are just there and they have no relationship. They're not complementary, they're not supplementary, they're not vertical. So that's a possibility. Okay, so again, pause the video. Once I've gotten all these written down, pause the video so that you can try it on your own. And then unpause it so that you can check to see if you got it correct or not. Okay, one more example real quick. All right, so get those copied down, pause it, and then do it on your own, and then check to see if you got them correct. Okay, so for problem number one, there is no relationship. Because if we take, first of all, looking at them, 70 degrees and 15 degrees, they're not equal. So therefore, we know that it's not a vertical or congruent relationship. So the only other thing that we can do to check is to add them together and see if it equals 180 or 90 degrees. If we add 70 and 15 together, we're going to get 85 degrees. So there's no relationship. This is one of those neithers. Okay, they're just a couple of acute angles. They're not having any relationship. Okay, if we look at problem number two, again, they're not vertical, they're not equal to each other, they're not directly across, in fact, they're adjacent to each other, so therefore they can't be vertical. So the next thing we do is we check to see what the sum would be. So we're going to take 110, add 70, and that's going to equal 180 degrees. So there's one of our relationships, supplementary. If it equals 180, it's a supplementary relationship. Okay, for problem number three, again, they're not vertical because they're not equal. So therefore, we can go ahead and add the two angles together to see if we get any relationship there. 26 plus 64 is going to give us 90 degrees. So that is a complementary relationship. Okay, for problem number 4, they're not equal. They're side by side, in fact. And if we take their angle relationship, add those two angles together, 60 plus 120, that is going to give us 180 degrees. So that makes it a supplementary relationship. Okay, for problem number 5, they are directly across from each other. So remember, if 52 opens up its door and looks straight out from its door and sees another 52, that is a vertical relationship. They are equal to each other. These are vertical angles because 52 degrees is equal to 52 degrees, and they are directly across the street from each other. Okay, and then the last one. We don't have any angle measurements written here. We have A and B written here, but remember that these little symbols inside of those angles mean that they are 90-degree angles. And if we take 90 degrees and add 90 degrees, we're going to get 180 degrees. So both of these angles are 90 degrees. We add them together. That's going to equal 180. That makes it a supplementary angle relationship. Okay, so we have supplementary here. All right, so some just quick little tips to help you remember what different angle relationships might look like. If we talk about complementary, a complementary, since it has to add up to equaling 90 degrees, remember complementary angles kind of form an L. So if you're looking at a set of angles paired together and it forms an L shape together, the two angles together are going to form it, then that means it's going to be complementary. So you would add and then set them equal to 90 degrees. And the reason I'm putting that down there is you add and set equal to 90 is because eventually you might have to solve for a missing angle relationship. So actually we're going to pause here. We're going to stop here and we'll continue our video tomorrow's lesson. Okay? Don't forget to go on to quizzes. You need to log on to quizzes and complete your assignment. It's just a 10-question assignment that you need to complete on naming angles, the types of angles, and the angle relationships. Just 10 questions, and there's no redemption.